August 12, 2026. Across parts of the world, the sun slowly began to disappear. The moon moved directly across the face of the sun. At first, only a small portion of the sun was covered. Then more and more. The daylight gradually faded as the moon's shadow moved across Earth's surface. And for a few brief minutes, the bright disk of the sun disappeared completely. What remained was something normally hidden from our view: the sun's enormous outer atmosphere, the solar corona. This was the total solar eclipse of 2026. And to understand what happened that day, we need to look at the precise movements of three worlds: the sun, the moon, and Earth. A solar eclipse is essentially an event of cosmic shadow. Light from the sun travels in every direction, illuminating Earth. But when the moon moves between the sun and Earth, it blocks part of that sunlight. A shadow forms behind the moon. If the central part of that shadow reaches Earth's surface, observers within it can experience a total solar eclipse. But the moon is much smaller than Earth. Its shadow, therefore, cannot cover the entire planet. Instead, it creates a relatively narrow path across Earth's surface. People inside this path can see the sun completely hidden behind the moon. Outside it, observers may see only a partial eclipse. This is why the same eclipse can look completely different depending on where you are standing. For one person, the sun may disappear almost entirely. For another, only a small portion of it may be covered. The event is the same, but the view depends entirely on your position on Earth. The moon orbits Earth roughly once every month, so it might seem that a solar eclipse should happen every month as well. But it doesn't. The reason is the moon's orbit. The moon's orbital plane is tilted slightly relative to Earth's orbit around the sun. Because of this tilt, during most new moons, the moon passes slightly above or below the sun from our perspective. Its shadow simply misses Earth. Only when the sun, moon, and Earth line up closely enough can an eclipse occur. And for a total solar eclipse, the alignment has to be even more precise. This is why total solar eclipses are relatively rare from any particular location on Earth. The moon has to be in exactly the right place, at exactly the right time. There is something remarkably strange about the relationship between the sun and the moon. The sun is roughly 400 times wider than the moon, but it is also roughly 400 times farther away from Earth. Because of this coincidence, the sun and moon appear almost the same size in our sky. That is what allows the moon to cover the sun so precisely during a total eclipse. But the match is not permanent. The moon's orbit around Earth is slightly elliptical. So sometimes the moon is closer to Earth, and sometimes it is farther away. When the moon is farther away, it can appear slightly too small to completely cover the sun. In those situations, a bright ring of sunlight remains visible around the moon. That is called an annular solar eclipse. But during the total eclipse of August 12th, the geometry was right for the moon to completely cover the sun along the path of totality. Just before totality, the atmosphere begins to change. The sunlight becomes noticeably weaker. Temperatures can begin to fall. The sky takes on an unusual appearance. And along the horizon, strange bands of light can appear. Then the final bright portion of the sun disappears. Totality begins. For a brief period, the brilliant surface of the sun is completely hidden, and something normally invisible becomes visible. The solar corona. The corona is the sun's outer atmosphere. It extends millions of kilometers into space and reaches temperatures of several million degrees. Under normal conditions, the corona is almost impossible to see, because the bright surface of the sun overwhelms it. But during totality, the moon blocks that intense light. The corona suddenly becomes visible around the dark silhouette of the moon. It looks like delicate, glowing streams of light extending outward from the sun. For those few minutes, the hidden atmosphere of our star becomes visible from Earth. The moon's shadow does not remain in one place. Earth is rotating, the moon is orbiting Earth, and Earth is orbiting the sun. All of these motions combine to make the eclipse shadow travel rapidly across Earth's surface. From space, the shadow can appear like a dark shape moving across the planet. At the center is the narrow region of totality. Around it is a much larger area where the sun is only partially covered. This means that moving just a few hundred kilometers can completely change the experience. One observer might see almost the entire sun disappear. Another might see only half of it. Someone farther away might see just a small portion covered. The same eclipse, the same moon, the same sun, but a completely different view. The darkness of totality affects more than just the sky. The sudden disappearance of sunlight can temporarily alter the environment. Some birds may behave as though evening has arrived and return to their shelters. Some nocturnal animals can become active. Temperature can drop as the sun's energy is temporarily blocked. And for humans, the experience can feel almost unnatural, because we are accustomed to the sun rising in the morning and remaining in the sky throughout the day. But during totality, the familiar rhythm suddenly changes. Yet from space, there is nothing mysterious happening. It is simply the shadow of the moon moving across Earth. A small shadow, created by an enormous cosmic system stretching across hundreds of millions of kilometers. Total solar eclipses will not always be possible from Earth. The moon is slowly moving away from our planet. The average rate is only a few centimeters per year. That is far too slow for us to notice during a human lifetime. But over hundreds of millions and billions of years, those centimeters add up. Eventually, the moon will appear too small in Earth's sky to completely cover the sun. When that happens, total solar eclipses will disappear from Earth forever. That means we are living during a very unusual period in Earth's history. The moon and sun currently appear almost exactly the right size to create one of nature's most spectacular coincidences. A small world can briefly hide a star. The eclipse of August 12, 2026, eventually came to an end. The moon continued along its orbit. The sun returned to its normal appearance, and daylight once again covered the regions that had fallen into darkness. But for a few minutes, the eclipse revealed something much larger than the event itself. Earth is not standing still. The moon is constantly moving around Earth. Earth is constantly moving around the sun. And every once in a while, their paths align with extraordinary precision. A small moon passes directly between us and a star that is more than 100 times wider than Earth. And for a brief moment, the universe allows us to watch a star disappear. Not because the sun has changed, not because the moon has swallowed it, but because of nothing more than distance, motion, and perfect cosmic geometry. A total solar eclipse.